Good day, and you're all very welcome to this week's CNPS technical session with me, Ian Cowan. Now, today we have one of our firm supporters of the organization, Jim Marsen. He's been around some time and he's made a number of very interesting contributions and papers, indeed, which are available. He has been talking for some time about the desirability of doing a Michelson-Morley type experiment in space. So in other words, not confined within the Earth's influence, whether that's gravitational or magnetic or ether, whatever you'd like to consider, but outside the Earth. And Jim says that such an experiment in low Earth orbit, it would be maybe the easiest, or even better, in solar orbit, will decisively disprove Einstein's special relativity. Now, this is quite interesting because many of us have theories which relate to the capture, if you like, of the actual electromagnetic radiation, or photons, if you prefer. Within the Earth, within an ether, let's call it that, within a medium, which is actually carried by the Earth in its solar orbit. So if you get outside that, you might be able to get rid of the very small, I don't say null, by the way, very, very small result of the MMX, the original MMX of 1887, which has been dismissed as nullity. Now, I do remember there was a very interesting sort of polymath by the name of Dr. Carl Zapffe in the US, who got into touch with NASA some years ago, and he had some discussions, and they seemed to be replying because he was a very well qualified and educated man. I think he was a metallurgist primarily, but he proposed something similar, I think, to what Jim is going to propose today to us. And the communication was cut off. NASA just wouldn't reply to his emails, or in those days it was letters. This is sort of 50 years ago more. So without further ado, it's my pleasure to bring Jim up. Now, again, as usual, just to remind you, there will be an opportunity to discuss things among yourselves in the chat. We would ask you maybe not to burden it too much, because if you send, one-liners every 5 seconds, it becomes impossible for me even to sort the wheat from the chaff, if you like. I'd like to sort out anything that really might merit a discussion later on. So, but I'm not inhibiting your to and fro conversations among themselves. Please try to keep them a bit pithy. And after going through the main questions and seeing are they related to what Jim has been talking about today, so we can put them to Jim. We'll then go to the green room and hopefully we'll have an interesting discussion. I see there are a number of people in, not too many at the moment, but maybe it's only 3 minutes past the hour, so we hope to come in. And again, as usual, I don't think we've really taken this up in practice, but I do always say that we like to give the speaker an uninterrupted facility to make his presentation. But in extremis, I think we can interrupt him. I don't suppose Jim would be very annoyed if we did say, Jim, there's something really urgent. Somebody has said this is so such. But if we can avoid doing that, we can leave the discussion to the end. But as I say, if there's anything really pressing that you really need to interrupt, you can maybe ask me. Jim. There you are, and great to see you again. And you have been participating actually reasonably frequently recently, and I know some time back I had the benefit of sharing a lot of information with you about the local ether and all that sort of thing. So so what we'll do is I'll you probably know the ropes. Have you sent me your file, by the way? Because you
I think so. It said it was sent.
Inbox. Let me just see. Yeah. So yeah. Okay, you have it here. So
okay, great.
Fine. So what I have to do is I just have to save that so I can project it for you. Okay, I've downloaded it. Right. So what I'll do is I'll give you the floor. The control will be yours, except that you'll have to ask me to put up the slides and to advance them, because I'll physically have to do that here.
Yeah,
And if there are any difficulties,
actually,
if there are
I
any, I'll come
probably
back.
prefer to make it more of an interview-like kind of presentation. I think I work better than trying to just do a straight presentation.
So, do you want me to put up the presentation immediately, or do you want me to wait
No, you can put it
until
up.
you?
Yeah, put it up.
Okay, so let me do that. Make sure it works. Good idea. Let me see now. Okay, well, first of all, I'll have to get it. It's in my system, so let me get it up. Okay, there it is. Now, okay, it looks quite impressive. So, what I'll do now is I'll bring it down, minimize it, so I can share my screen. So this will just take a second. Share screen, entire screen.
This is actually adapted from a presentation I made at 2019 CNPS conference remotely.
So can you all see that? If you can see it, Jim, I'm sure everybody else can.
Yes.
Does it look all right to you? Okay. And I see the slides are in the left side. You don't want to change that, or you could actually maximize that. I take it, by the way, it's filled your whole screen. We don't have photographs of yourself and myself there, do we?
No, actually,
because what you see something different from what I see.
Yeah, I see both of us on the side.
Oh, okay, I don't. Okay, that's the only difference. Doesn't matter.
Okay.
Okay. Well, the floor is yours now.
Okay. So this is not a new proposal, actually. Next slide, I guess. Can you go to the next slide?
The audio has gone a little there. Yeah.
Okay.
Okay. The audio. I missed the audio.
Yeah, these are just my education. You can pass this. Next. And next. You can go back to that later. This is all right. So, like I said, this has been proposed before, not just by me, but a member of Professor Howard Hayden has also proposed it. It was in Tom Bethel's book, is Relativity Necessary. So the key here is that if you do the Michelson-Morley experiment in low Earth orbit, it will, if the local ether idea is correct, if the ECI, if the Earth-centered inertial reference frame is the actual privileged reference frame for electromagnetic radiation in the vicinity of the Earth, it will be moving with respect to that reference frame at the orbital speed of the satellite. So it should detect the same kind of fringe shift or frequency shift that has been sought after since the original Michelson-Morley experiment. And the reason that it should work in outer space instead of on the ground in a lab is that this same ECI privileged reference frame that is fixed in direction in the vicinity of the Earth means that the lab is only traveling at the rotational speed of the Earth of this. So it's at the equator. That's like 465 meters per second, whereas the assumption of previous well, essentially almost everybody is that if there is an ether, it's absolute. It's the same everywhere. It flows through the Earth. It doesn't flow around the Earth. And the Earth and the speed of the interferometer should be equal to at least the orbital speed of the Earth around the Sun, 30,000 meters per second. But if it's only 465 meters per second, because it's only due to the Earth's rotation, then it's too small for the original Michelson-Morley experiment, or in fact, any mirror-based interferometer to detect. It would be 1/4000th of what they thought, what they were looking for. So even the results of Miller's experiments or Jews or any of the experiments that have done it up until 1979 just couldn't detect it because it's too small. Does that make sense to anyone? Well, think about it anyway. Then in 1979, there was an experiment called Brier-Hall, done by Nobel Prize winner John Hall, that was actually looking for the standard idea of an absolute reference frame. Only this time they thought they could find it due to the CMB dipole, which would actually be approximately 400,000 meters per second towards the star, I think Vega or something, or Aldebaran. And they saw a signal, but it was very small, and they dismissed it as spurious because they couldn't conceive that it could be due to the Earth's rotation. This was one of the first experiments that were done with lasers, and it actually was sensitive enough to barely detect the Earth's rotation. But like I said, they dismissed it. So Howard Hayden, who was a supporter of Peter Beckman's idea, who was one of the first to seriously propose that the reference frame for electromagnetic radiation should be related to the gravitational field around the Earth, gravitational potential around the Earth. In other words, what I call, or what is later called by another professor scientist that I support, named Professor Cheng Chuan Su from Taiwan. Which essentially means that, again, the speed of the Michelson interferometer on the ground, on terrestrial, is only 465 meters per second, not 30,000. And he analyzed the results that Brier-Hall reported and showed that they actually do support detecting this velocity. or this fringe. Actually, they used what's called a Fabry-Perot echelon, which is sort of like other modern Michelson-Morley type experiments that use what are called cavity resonators. And instead of looking for a fringe shift, they're looking for a frequency shift. But anyway, so that's one example of why maybe it's just too small for all of the previous mirror-based interferometers to detect. And again, if it's due to the Earth's ECI as the reference frame, then in low Earth orbit, you're going 7,600 meters per second instead of 465, which is like 20 times faster. But since it's a second order instrument, the interferometer, it's actually 400 times greater signal. Okay, I'm getting a little nervous. I'm sorry. Can I open for comments now to see if anybody's following me?
Sorry, I didn't hear that. Did you? What did you say, Jim?
Yeah, could I open it up for
Did you have a
comments
request
now?
there? No.
See if anybody's following me. All right. Well,
Your sound is breaking up, unfortunately. Say again.
Huh. Yeah, I was just wondering if anyone understands what I'm trying to say.
Shall I go back to the slides?
Okay.
Yeah, I didn't hear anything. Just broke up. Didn't hear what you said. Are you checking that everybody is following you?
That's what I'm asking.
You're doing very well. Shall I go back to the slide? Yeah, no, it's excellent. It's perfect. And you're speaking nice and slowly. Sometimes people rush it too much.
Yeah, that's because I'm not as prepared as I should be.
Shall I go back to the slide?
Winging it. Okay, fine.
The only problem we're having is there's an intermittent problem with your voice. It's working 90% of the time, but when it cuts off, we hear nothing.
Yeah, I'm trying to use a headset, so I thought that would is the volume okay? It's just that must be. I mean, anyway, let's try the next slide.
The volume is perfect. I have to bring myself up before talking. The volume is perfect, actually, and your voice very clear.
Okay.
Would you prefer that I have a sort of a slide mode where your particular slide fills the whole screen, or leave it in the original where all the others are in a banner on the left-hand side?
Yeah, let's try that. Maybe the sound will be better.
Is it better to fill the whole screen, is it?
Let's try that, yeah. Well, anyway, okay, yeah, you can go to the next slide. Actually, I want to mention that there were two physicists in 1986 who actually got a letter to Nature published proposing the MMX be done in outer space, but their only argument really was that, well, we never tried it, so let's try it. But here we're having and Carl Zapfi, from what I read of his paper, was his thought was that it had something to do with the ionosphere around the Earth, blocking the, I guess, the velocity of the Earth's orbit from reaching the ground. Others have thought that maybe that, well, actually, George Stokes in the 1850s, I think, proposed that the ether was following the Earth in its rotation, so that the velocity of the Earth relative to the ether was essentially zero at the ground. But this is a different idea, that it rotates within a stationary or an ether related to the ECI, which is essentially points in the same direction relative to the fixed stars. So it's, as Beckman said, it's like a woman wearing a hoop skirt, but the hoop is detached from her body. So if she spins within the hoop skirt, doesn't rotate, but she's spinning. So that's the difference between the local ether model of Beckman and Sue from the Stokes model, which was dismissed. And I think that both Beckman and Sue showed a lot of evidence that this alternative idea works. And there's other evidence, primarily due to the Sagnac effect. Now, the Sagnac effect was shown in 1913, where he took what's now called a Sagnac interferometer, and he rotated it. And from then on, everyone has assumed that the Sagnac effect was dependent on rotation. And there have been arguments back and forth where can special relativity explain it, or is it due to a classical interpretation? I don't think any of there have been like 30, I think, different proposals to explain it in the context of special relativity, but they've all been shot down or found to be flawed. But the Sagnac effect, if you consider classical propagation in a medium, say a water wave on a pond, or air, or any real physical wave that you can think of in a medium, it's only due to the motion of the receiver with respect to the medium during the propagation from an emitter. Think of a quiet pond, and a toy boat. Now, if you drop a rock in the middle of the pond and the waves propagate out from that spot, first of all, once the waves are created, the movement of the rock or the emitter has nothing to do with the propagation of the waves. They're just propagating through the medium. And if the toy boat is not moving with respect to the medium, it takes a certain amount of time for the wave to get to it, for the leading edge of the wave to get to it. But if the boat is moving toward or away from the point where the rock was dropped, it's going to take longer or shorter time to reach the boat. That should be clear or obvious, trivially obvious. And that's the Sagnac effect. It has nothing fundamentally to do with rotation of the Sagnac interferometer. It's just movement of the receiver with respect to the medium during the propagation of the wave. So that's been a major mistake. It's hard to believe how people don't understand that have any understanding of waves, mediums. But so the point is that the Sagnac effect can be a linear effect and not just due to rotation. It happens that if you analyze the way the Sagnac interferometer works, it's splitting a beam of light around usually a circle or sometimes a triangle, or other. But it's sending the same beam that's been split in two different directions, and then they meet up back at the source. And if you consider classically the propagation, one takes longer to get the one that's because the receiver is moving. One leg takes longer than the other to get back to the interference point, and you get a French shift depending on how fast the receiver is moving. But and if you look at the formula that comes out, you can interpret the area enclosed by the path as affecting the strength or the magnitude of the French shift. So a lot of people say that area enclosed is a crucial factor in the Sagnac effect, but that's just a different way of arranging the components of the path and the speed of rotation. The real Sagnac effect that I just described, of just movement of the receiver, doesn't have anything to do with area. It just happens to be an equivalence in a sense. So anyway, we know that the Sagnac effect is real. And another point is that it's a first order effect. It's proportional to v over c, the velocity over the speed of the medium, the velocity of the receiver with respect to the medium divided by the speed of the wave in the medium. So it's a lot easier to detect than a Michelson interferometer can detect motion of the instrument with respect to the medium. Because when you reflect the light beam off a mirror, for example, you effectively cancel out the first order effect, and you're left with a second order effect proportional to velocity squared over c squared, which is a much smaller signal. So it's much harder to detect for v over c relatively small value, at least. I guess if the velocity gets up close to the C, that effect becomes stronger, but it's still smaller than a first order effect. And one confusion that I've noticed, what I consider a confusion, is that some have analyzed the Lorentz transformation, second order Lorentz transformation, and try to say that something is different about the propagation of light or electromagnetic radiation for I don't know, small, well, second order instruments, essentially, like the Michelson-Morley interferometer. There's something different about the physics of propagation of light, which requires a Lorentz transformation or a Solari transformation, or I think there's another Tangerlini transformation. There are other transformations that have been proposed to explain the supposedly null results of the Michelson-Morley experiment. But I'd like to make the point, and others have, that a few others have, that the physics of propagation of light has nothing to do with whether you're measuring it with a first order instrument or a second order instrument. And I think that's an important point, because if Michelson-Morley type experiments, if they're not totally exactly null all the time, if it's just that it's too small for the instrument to detect because it's second order, then you don't need those transformations. And I guess that's what I'm trying to say in this slide. It's been a long time. I actually didn't review them, but and all right. So next slide, perhaps. I think I've kind of gone over these points. All right. So next slide then. All right. So now we have GPS. And the GPS, if you read the media, the popular media about GPS and other physicists, perhaps relativistic accepting physicists, depends on special relativity and general relativity. But that's only for the clock tick rate, which needs to be talked about separately. But the fundamental truth about the GPS system that is not explainable by special relativity is what's called the pseudo range correction. So every GPS receiver has to account for this. It's effectively a Sagnac effect, a linear one-way Sagnac effect. Has nothing to do with rotation. Nothing to do with rotation. Essentially the same thing that I described with the toy boat. When a GPS satellite emits a signal, a pulse, it travels to the receiver, but the receiver is moving due primarily to the fact that it's on the Earth, and the Earth is rotating with respect to the ECI, the Earth-centered inertial reference frame, or essentially the local ether, the privileged reference frame. And it takes about 1/10 of a second, about a millisecond, to get from the satellite to the receiver. It's moved as much as 40 meters from where it was when the pulse was emitted. And that's assuming that the receiver is at the Earth's equator. But and the GPS satellite is essentially tangent to the Earth's surface. It's effectively just rising off the horizon, so it's behind effectively the motion of the receiver, or the receiver is moving directly towards it at that velocity of 465. And if you don't account for that change of direction or change of position of the toy boat moving while the wave is coming at it, then you'll get this 40 meter error. And to point out also the fact that this motion of a receiver with respect to the rotation of the Earth is smaller and smaller as you go farther away from the equator. It's a cosine of latitude function. So at the location of most experiments, the moderate temperate zone like New York City or Europe or whatever, it's only around 300 or 350 meters per second. Or, for example, where the Brillet Hall experiment was done in Colorado, Boulder, Colorado, I believe. It's like 350 meters per second. And then at the pole, obviously, it's zero. So, and the other point that people often don't think about is that it's always due east to west, no matter where you are, no matter what time of day. And that's what's tripped up a lot of the experiments that have tried to detect an ether drift, the modern experiments using cavity resonators in particular, that they essentially are looking for a signal due to the absolute model of the ether, that and analyze their results, average their results, process their results in a way expecting that their instrument is pointing towards the stars, is what matters, and essentially average out this signal that they might be able to detect but if they average the signal right, but essentially throw away. So that's another factor that's part of the confusion of nature that is vested on scientists, that should be a lot more obvious to anybody that's not wedded to the null results in special relativity. But how am I doing on time? So my point is that some experiments, like for example, Kennedy Thorndike, don't rotate the interferometer on a table like the original Michelson-Morley and many of the other Michelson-Morley type experiments do, because if you're well, the idea being if there is a velocity of the or speed of the device with respect to the medium, you have to change the direction of the light beam to be either directly into the parallel to the direction or at right angles to the direction. You have to rotate it to see a difference. If you just stick it there and it's always in the same direction, it's never going to show you a fringe shift change, a shift or a frequency change. But if you assume that the ether is stationary with respect to the universe, then you're expecting the Earth's an orbital motion to affect where you're pointing relative to the ether instead of rotating the instruments. So a lot of the experiments that report these fantastically minimal velocities, like 10 to the minus 8th or 9th or 12th or I think 17th now, it's all due to the averaging based on the assumption of the universal ether. So I guess it's, it could be possible if instead of having to launch it on a satellite or put it on the ISS, which would be ideal, that if you did a careful experiment looking for this motion with respect to the ECI, this 300 to 400 meter per second motion, and averaged your results that way, that you might see something. You probably would. But the easiest and the cleanest way to do it would be to put it in Earth's orbit. So there would be no disputing about how you're processing your data. It would be clear and unambiguous. And that's the crux of my argument for it. Whereas like others may have other arguments. Okay, next slide. So again, this concept or analysis essentially of the local ether model, the halo, the ether forms a halo essentially related to the gravitational potential. Any large mass is going to produce gravitational potential, and if that has a variable density or variable strength, I should say, as you go away from the surface. And essentially that's what Su and Beckman proposed as their paradigm shift or fundamental hypothesis for the propagation of electromagnetic radiation in the vicinity of the Earth, that it's associated with the gravitational potential, which doesn't rotate with the Earth. And as you travel away from, as you go farther and farther away from the Earth, you eventually reach a point where the gravitational potential, the gravitational field of the sun, solar system, becomes dominant. Essentially, like the L2 Lagrange point, where there's a balance between the gravitational attraction of the Earth and the gravitational attraction of the Sun. So that is what Sue proposed as the extent of the local ether around the Earth, and the idea that it's the preferred or privileged reference frame for propagation switches to stationary with respect to the Sun and the solar system, and that every large mass, celestial sized mass, like another planet, also has its own local ether halo surrounding it, that it moves with it but does not rotate with it. And even you can imagine that eventually the local ether halo surrounding the solar system gives way to the Milky Way's local ether, and so on and so on. Local galactic clusters, superclusters. I don't know about farther away than that, but that it's associated with and defined by the dominant gravitational potential. And we could get into that more at some point. Actually, I think I've done a presentation regarding that in the past, but the key here is that if we can detect this positive result for a Michelson-Morley experiment, that's the clearest and hardest to dispute disproof or invalidation of special relativity that's possible. That all the other attempts to try to disprove it based on logic or math or thought experiments, they still come up against the experiment that led to special relativity in the first place, the Michelson-Morley experiment, that supposedly has absolute total null results down to 10 to the minus whatever, according to modern cavity resonator instruments. I would like to point out another thing is that one of the most recent and precise, supposedly Michelson-Morley experiments by Nagel et al. In 2015 actually has a passage that that they do see this 2 omega signal when they analyze it with Fourier analysis, that has been persistent in a lot of the experiments that do rotate. Some of the cavity resonator experiments didn't even rotate, so they couldn't see anything due to the Earth's rotation with respect to the ECI. But they said that if we didn't think it was impossible, this could be interpreted as a real signal. The 2 omega means that as you rotate the instrument on a horizontal table, as it points to different directions of the compass, is going to have like a sine wave, as the device points in different directions. There's a shift in the frequency or fringes happening at twice the rotation rate. But he said, well, it's probably just due to magnetic interaction with the Earth's magnetic field. But of course, they never got around to shielding it against that. But and if you don't average it right, you're going to cancel it out anyway. But an interesting point, I can show you the paper at some point, but I don't have a I can't pull it up. We pull it up right at the moment. Well, I did quote the guy in my paper on the topic that's on ResearchGate and Vixra, proposing the MMX in space idea. Oh, and let me also point out that even if there's an attempt to claim that if there was a positive result, there are probably going to be people that scientists trying to explain it in terms of possibly general relativity or something. It would at least perhaps be an argument to now do it in Earth's orbit, interplanetary Earth's orbit, which is obviously more expensive to try to do. So you would want to do the Earth orbit version first. But if you do it in the interplanetary orbit, where you're moving relative to the sun's ether, or the solar system's ether, you would be moving at the full orbital velocity of the Earth. You take away, you get away from the Earth's local ether, and so you'd be moving at the 30,000 meters per second. The original and all other MMXs to date have been seeking. But now you'd see that signal that you were seeking, because you're moving at that 30,000 meters per second. And then there would be no way to dispute that what led to the experiments that led to the invention of the Lorentz transformation, or the Lorentz contraction, or time dilation, or all the baggage that comes with the null result of MMX experiments, would be much more difficult to dispute, since that's essentially the experiment that led to special relativity. All right, next slide, I guess. So the question is, if we do support the idea of doing this, how does it get accomplished? You try to propose anything, like you said, like Ian said, that when Zapfi brought up the idea, he was totally dismissed at that point, and others who might have proposed that can't get past first base. Any committee that decides what experiments are to be done, since any kind of launch is very expensive, even if you're doing a ride share with other experiments and satellites, it's always would be rejected, because the committee members are supportive of special relativity or Einstein's relativity, including general, think you're a crackpot. And or even if they thought there was some merit in trying it, they wouldn't have the nerve or the to accept it, because they'd be afraid of being ridiculed by the rest of the mainstream scientific community. But now that there's been a number of private companies that have built a ability to launch satellites. You just pay them the money, and they'll launch a satellite for you. They're less susceptible, although still possibly susceptible, to being criticized for trying something that has no validity or possibility of succeeding, according to the mainstream community. And I at one point I thought maybe other countries like India that have capacity to launch orbital satellites, like India or China, might be more open-minded, but I don't think so, actually. So the key is to drum up enough potential support, or to find a financial angel somehow that would front the money for it. Probably be like $1 million or $2 million to do. But the key would be that you're relative to other experiments, like the hundreds of millions or possibly billions of dollars that have been spent trying to detect dark matter, for example. This is like a drop in the bucket, a month's salary for like LIGO or something, or LIGO, or whatever you want to call it, looking for gravitational waves. So it's a big risk in some people's mind, or a much bigger reward for fundamental change in physics, possibly. Oh, and I also wanted to point out that there was an attempt to look for a fringe shift due to the Earth's motion in space by the LIGO experiment. They temporarily set up to look for that. But as I pointed out before, if we're talking about a constant east to west velocity due to the Earth's rotation, there's no way they could have detected anything, no matter how sensitive they were. So next slide. Do I have any more? Just again, in summary, let's do it. Let's get all the dissidents together and fight for it. It's the only way we're going to really overturn Einstein's relativity. Thank you. Yeah, that's it.
Well, thank you very much. I'll have to stop sharing my screen, so just give me a moment. Let me see now. Stop screen. Okay, I think we're back to normal now. Well, thank you very much, Jim. That's been an excellent exposition of a subject. Now, I'm biased. I better put my cards on the table, because I've been looking at this subject for maybe the last 30 years, and I've come essentially to the same conclusions as Jim has expressed in his presentation. I think it's been very succinct. So,
well, we got one
have to
supporter
keep
at least
questioning things. Now, Yeah, right. Well, I certainly support you. Although I do have some slight pessimistic doubts, which you have expressed in some of the slides. I think perhaps we should keep on chipping away, and maybe we'll get somewhere ultimately. But what one from previous experience could extrapolate and say, oh, the mainstream would still want to maintain their orthodoxy, and they'd introduce some other ad hoc hypothesis. Which indeed, as we keep chipping away, as I say, might be more difficult to do. So we certainly should keep at it. And I was wondering if we could persuade somebody like Mr. Musk, who's now in the administration, in this direction. There might be some possibilities.
Yeah, he probably makes more in interest in a day than it would cost.
It would actually, yeah, politically, yeah. Yeah. Actually, just one of the last points you said, the local ether, which is an interesting way of looking at it, could be a candidate for dark matter. I wasn't quite sure what you were getting at there, Jim.
Well, if there's a medium, if there's an ether, if there's a medium, it's got to be a real mass. It's got to be a real thing, which means it has mass.
Okay, so the mass, yeah.
I think. I mean, that's the key. But it wouldn't be these free particles that they talk about as dark matter candidates. It would be more like a liquid in the sense that whatever particles make it up would have to be in contact with each other and interact with each other. But it would have to have real mass, and if the mass density were proportional to or a function of the gravitational potential, which is essentially what I'm claiming, then it would also explain why light travels slower in a higher magnitude potential, gravitational potential location. You'd have more particles essentially to travel through, and it would take longer to travel through, so the speed of light would be slower in a denser region, and that would explain things like gravitational lensing, the Shapiro time delay, even high Foucault. And Sue even proposed that and analyzed it and showed how the clock ticking is faster for the jets traveling west versus east. And it comes out very clearly from the fact that the jets are traveling faster with respect to the local ether going west than east, because they're
okay, maybe just two observations before we get to the questions.
Okay.
Probably nothing to be said because I just points. One is, I note correctly. You say that these transformations and Fitzgerald-Lorentz
contraction,
gave the base to SRT. But it's interesting to note that Einstein claimed that when he wrote the 1905 paper, he was unaware of MMX. Now, you might doubt that.
He had to be. In fact, the first page of his paper, he says that the speed of light it's two-way speed of light is half the each way
to measure it,
which is essentially the conclusion of the MMX experiment.
And the other observation you made about the Sagnac not being restricted to nonlinear motion, it's well taken. And some experiments, interesting experiments, have been done with optical fiber conveyors by Rudong Wang, who has been in touch with us, by the way. I was trying to, I think I've mentioned it before. I was trying to persuade him to give a talk to us, and he said he couldn't at that time, but he'd like to keep in touch with us. He was very forthcoming. I don't know what the reason was that he wasn't willing to speak. It might be the language or something. I'm not sure of that. Now, you'll have to forgive me, Jim.
Yeah, I forgot to mention that, but I was thinking of mentioning that. And I also forgot to mention that Sue derived the change in the dependency of atomic clock tick rate on velocity with respect to or speed with respect to the local ether, and
this chestnut atomic clocks are adjusted by this gamma factor.
It's the clock. It's the clock being affected by the environment, not some kind of mystical, magical change of time.
Okay. Well, since I was presenting the slides on my screen, I have not looked at the questions. I've had a quick look at them now. I don't know, maybe very briefly. I mean, question, as just said, the original conception of the ether, which Michelson-Morley accepted, was that the ether only propagated light, and light is electromagnetic. So how could electromagnetism serve as ether?
Light and electromagnetic waves are equivalent in my this discussion. It's just a
yes.
Everybody talks about light, so even though it's really electromagnetic radiation waves that include light.
Okay. I'm just we shouldn't take very long to go through some of these, but okay. Here's a further question. Well, I think question is just saying, what is your view of length contraction? If it is a valid theory that the ether pushes objects to shorten, wouldn't the phenomenon occur in outer space?
Well, length contraction was invented by Lorentz as a clue to explain the null results. So if you don't have null results, you have real results, positive results, then you don't need length contraction theory or hypothesis or space contraction, which is what Einstein essentially extrapolated to, because Lorentz contraction was only meant to explain in a microcylinder where the distance between the mirrors is controlled by physical bars. But Einstein was saying that length contraction occurs in space, in outer space, between emitter and receiver, where there's no electron, there's no physical connection.
Well, at least Lorentz had some physical basis for it. He said, well, if there's something like this, it would be electrons, moving towards each other, being pushed by an ether. But Einstein didn't talk about that at all. It was just a
magical
geometrical effect. The question is going further. Would the MX experiment in outer space tell us that the ether exists, or could it tell us the position of the ether also?
I'm not sure I understand that question.
Yeah, it'll tell us maybe. It'll indicate the effects maybe vis-a-vis a local ether and being outside the local ether. Maybe that's the best way. He's come again. Question is asking a lot of questions, but he says, is it specifically gravitational thing? That's something I noticed as well, that you take the gravitational potential basis as distinct from perhaps the magnetic. You referred to Zapfi's preference for maybe the ionosphere. Sorry, just a second. I'll just
Sure.
with you in a second. Sorry about that. Just some animal problems there. So you take the basis of the gravitational field as maybe defining the ether, the local ether.
Yes, that may be an. I mean, I think Sue kind of touched on it, but he didn't really dig into it. So that may be more of my own.
Well, there are a lot of questions coming from question. It's Jerry Harvey, actually, since we know him now. He talked to us 2 weeks ago. So that's his nom de guerre. And if he wants to put some of these questions to Jim, I'm sure you'd be able to take them up in more detail. Temperature, let's say. Okay, I'm just looking at the time, and I want to get some people in the green room in, because there has been some private chat as well. So just I'm nearly through with this. Okay, and if I'm missing anything, you could maybe post it in there again. Say this is a specific question for Jim, not just a conversation between us. Actually, Professor Helen Boutier says, I support this model. The Stokes-Planck-Beckmann ether. Well, you sort of distinguished a bit from the earlier Stokes idea, which didn't encapsulate a movement between the spinning of the Earth, if you like, and the non-taking up of that spin.
Yeah, I think that's a key difference.
Yeah, exactly. He's lumping it all together, but anyway, Stokes certainly had an ether drag model, which is part of the.
And I think in 1905,
dragging the ether through the revolution around the sun. Okay.
I think in 1905 there was a brief proposal by Planck and I forget who else of a ether that was entrained and fell off farther from the surface, but they essentially retracted it when they decided that it didn't work out from a pressure standpoint. I'm not sure exactly why they retracted it, but
I haven't noticed this gentleman before, but he also says that I think my work could be of interest to the audience by ignoring the theory of relativity and the analysis of electromagnetic problems with moving objects. We have developed a new EM software. Well, if you'd care to give us some references, we could have a look at that.
Actually, I've had a couple of messages back and forth with him on ResearchGate. And
okay. And he makes the same point about the linear Sagnac effect. Experimental, yeah. Okay. Well, yeah, he's got more things about the first postulate. Okay. There's a lot of talk about inertia and Galileo's relativity and so on. Okay.
Yeah, actually, I would make a point that this idea that all reference frames are equivalent, that Einstein says that may be true for mechanics, but if there's an ether, if there's a medium, that makes things different. That there is, all reference frames are not equivalent for electromagnetic propagation if you assume a medium.
Yeah, so, and surely that is what gives the reference point, because Newton's first law, if you like, the relativity of Newton's first law, would be vitiated by having an atmosphere, say. So you could, maybe by friction through the atmosphere, or otherwise, you could get a wind. But in an ideal situation where there would be a vacuum, the first law applies, and there's no difference between movement in a straight line at constant velocity, in other words, and stationary movement. But so in the same way, if you're extending that to electromagnetic phenomena, you have the problem that you have an ether in our theory. Sorry, just excuse me a second. Yeah. I do apologize. It's my cat. I just really needed to be let out. So you have the ether as a reference frame, and that's where ideally, if you didn't have such, you could perhaps extend the principle of relativity to at least insofar as constant velocity to other phenomena.
Yeah, actually, there's a comment here. I want to make a point that regarding dark matter, should be fairly obvious. But if dark matter is the ether that transmits electromagnetic waves, it's the medium. It's not the wave. So you obviously could not ever expect to detect light due to the medium. It's just the transmitter. Do you follow me? They keep saying, well, why is it invisible? Or why can't you see, why doesn't it emit anything to detect? Why can't we detect the particles that are supposedly are dark matter? It's because they're not particles in the sense of a particle. They're the medium. It's the medium.
Yeah, and you pointed out that what's all the fuss about? I mean, there's no difference in connection with dropping a stone in a pond, as you eloquently stated, and you can see for all wave motions, sound and air or whatever, the original.
It's not the medium producing the waves. They're just transmitting them.
Yeah, exactly. And the speed is independent of the speed of the emitter, not the receiver. Oh, right. Okay. There's a lot of conversation, and if you've noticed anything that I've missed, or anybody said, "Look, I made a comment 15 minutes ago and you've missed it," just put it in again. But we have some time now to go to a more full discussion, and I see there has been some private chat. Again, forgive me, I haven't been able to look at it. I think Jim Keane had some questions there, which maybe he can put directly. Light speed change versus energy density, exactly the binary result locally. I think it maybe so. So I'm looking. There's everybody in the green room has his camera on except Slobodan. Yeah, he has it now. Okay, so. And I think he's put his hand up, but I'll ask for volunteers in a moment. I'm going to bring and I'll bring Danny up as well. I'm going to bring James Keane up first because he has about 5 questions here, and I'll let you, Jim. Hello, Jim. Good day to you. Hi. Put those directly to Jim or any other points you have at issue.
Well, are you saying, Jim, that? Well, thank you, Jim, for your presentation first. Are you saying that the light is going to travel at different speeds depending upon the direction of the arms of your Michelson interferometer?
Well, that's the whole idea. Is that if the light beam is pointed in the direction of the the flow or the motion with respect to the medium, it's going to be supposedly take longer or shorter than if it's pointed at right angles to the motion.
Okay. Let's see.
And it's
So for example, when you talked about the Sagnac experiments and so on, there was also one done later in Christchurch in New Zealand, and there they found that the retardation was in the opposite direction because you're in the southern hemisphere.
Well, also, I was going to actually mention that. I forgot to. It's a ring laser, and I was just reading about it last night. It was built in the 90s, and it detects the Earth's rotation, like as if it were rotating, but it's due to the Earth's rotation. And
which is what the original Michelson-Gale did.
Yeah, I was just going to mention that. It's the Michelson-Gale was a quarter of a mile on a side, and this is the ring laser in Christchurch is like a couple of meters in each, a rectangle that's a couple of meters on a side. And there's also one built in, I think, Berlin or somewhere near Berlin, and another one, and it's also I just read that they're proposing an even bigger and better one with three-dimensional to look for more like a seismometer, a very sensitive seismometer.
And of course, they're all used for navigation now in airplanes, for example. Commercial airliners, originally military ones had them, but commercial airliners use ring laser gyroscopes instead of
inertial
mechanical one
with gyroscope, with physical gyroscopes, right? And I read somewhere that even those small ones use the Earth's rotation to calibrate themselves. That they can detect it, essentially. And I was going to show you a video by Doug Moret. He built one in his basement or his home lab with a kilometer of fiber optics wrapped around like a 1 meter in diameter circle that detects the Earth's rotation due to the Sagnac effect.
You can get these things on the internet for a reasonably low cost, I believe. Set it up yourself.
I think he sells a kit to do it yourself.
Okay.
And he also has a great video showing the pseudo range correction calculated from GPS data with that is collected at various stationary receivers around the world. And he shows how when the satellite is opposite the direction of the Earth's rotation, it takes longer. And if it's traveling toward us, a satellite is in front of the direction of rotation, it's a shorter time. So in all these Sagnac experiments, I also want to point out that the medium, the speed of the wave in the medium is constant, but the effective speed to the receiver changes because of its motion with respect to the ether. So it's not really a change in the speed of light. It's kind of an effective change in the speed of light.
Yeah, it depends which frame you look at. I mean, if you're looking at it from the absolute frame, let's say, the ether frame, let's say the local ether frame, as you pointed out earlier, Jim, it's the relative distances which are changed. In other words, the receiver is approaching the transmitter or it's receding therefrom. However, if you're on the unit which is moving, well, then it's C plus or minus V.
And I also want to point out that Sue's analysis of the Sagnac effect contains a second order factor, and but it's so small.
Yeah, because v is small.
And it's v squared over c squared.
Right.
So it's like for the Earth's rotation, it's like 10 to the minus 12th or 6 times smaller effect, and that's the Lorentz transformation effect. It can't account for the first order effect, the first order formula.
Okay. Well, Jim, anything else?
It's too small. It's too small.
Yes, I have one additional curiosity. We're talking about putting this an interferometer, in Earth orbit, and then even further out into, I guess, interplanetary space. And yet, at the same time, we're talking about apparently different ethers. I'm wondering if you could clarify that. Like, you talk about a local ether, and if you're going to go out to interplanetary or even, let's say, intergalactic space, theoretically speaking, or hypothetically speaking, wouldn't there just be one ether we're talking about here? I mean, why so many ethers here?
Well, it's effectively the same ether in the sense that it's just different densities and essentially different densities. It's the same material, whatever it is, made out of the same particles. It's just different configuration. It's like the atmosphere. It's the same atmosphere.
So you're saying that the ether
densities.
actually varies in density. Energy density.
And it's proportional to or a function of, basically proportional to the.
You say the
gravitational potential. It's 1 over r, or above the surface of the Earth, until it meets.
Okay, thank you.
Until it meets the sun's.
Okay, well, thank you for raising those points,
yeah,
Jim. I mean, that seems intuitive. It seems sort of really common sense.
It's so simple when you think about it.
Maybe we need more experiments to show it definitively.
Well, if the ether is a medium, you're saying that actually the medium is not uniform in the universe then.
Exactly. That's the key. That it depends on the strength of the gravitational potential, that it's variable.
And for my part, I mean, the traditional argument between etherists and non-etherists, or people who didn't believe in any such thing, was that the proposition was put that the ether was a universal frame, which was the same everywhere, and it couldn't move, and so on and so forth. Now, the local ether,
and that's just an assumption. Why does it have to be
an extreme assumption?
It's maybe the simplest assumption, but there's no proof to that. There's no reason to.
Well, thank you.
It can't have a different.
You've expressed that well, and you brought that to our attention.
Yes. Well, thank you, Jim.
Okay.
Thank you, Jim, James, Jim J. I'll bring it down now. Thank you.
Jim 1 and Jim 2.
Yeah, Jim 2.
All right.
Okay. Now, I have a couple. I think Denny has his hand up, so I'm going to bring you up, Denny, now. And what is your contribution or your suggestion?
Well, there's been an experiment done, an electric motor with an armature. To start up the armature, they clicked it on, and it took a certain amount of time to get up to speed. Then they turned it off until it stopped, and then turned it on again right away. And it took less time to get up to speed. Whereas if they waited 5 minutes, say, and then turned it on again after turning it off, you were back to the old slower startup until it reached maximum velocity, maximum angular velocity. So that there must be an ether, and it must be partially entrained by matter. And this gets me into Ian's model, where he has a paper where he explains that if you assume that the ether is a certain percentage, it follows the matter as it moves. If you explain a certain percentage of that following, then you get the right answer for the Miller experiment, I believe it was that he said. Is that right, Ian?
Well, I think maybe in the first instance it was a very slight discrepancy in the Michelson-Gale experiment, 2.7% or something. And if you do exactly what you say, you get the right answer. I think, is that what you're referring to?
And you mentioned, Jim, that the Miller experiment couldn't detect the effect that you're talking about because it was too small. But Miller, at one point, decided to use sidereal time rather than regular time. And he did get a sine wave. Here's the plot on page 232 of his book, In the Grip of the Distant Universe. And here's the plot. Let's see if I can, I hope it's the top one is the sine wave that you got in sidereal time, and the bottom one was regular time, which didn't really show much.
Random.
So it seems that, Jim, the Miller experiment was able to detect some sine wave type motion, but only if it was so delicate that only if you use sidereal time, which you mentioned, I believe, in your talk, which is its time relative to the fixed stars rather than revolution around the sun, that they could get that sine wave better. And then you were talking about experiments. Ron Hatch, the GPS guy, sent me this paper. I don't know if can you read that or not? This was the diagram he sent, and he called his paper tolerable asymmetry, meaning that he did not agree with Einstein's assertion that everything was symmetric. He went on the basis of asymmetry of inertial frames. And but unfortunately, he died before he could publish this. He died suddenly, and I could send you this if you're interested. And the paper wasn't complete. He had some things he was still working on, and I was trying to help him, but then he died suddenly. Ron, who was the best of the last and the best of the GPS guys, and was able to get accuracy to not just centimeters but millimeters, maintained until the day he died that there was asymmetry, not symmetry, and in inertial frames, and therefore the special relativity and general relativity both were incorrect. And he does have a paper he did publish, which was 2007 in Physics Essays, where he again made this point, but he had gone quite a bit further when this paper I just showed you. And he maintained until the day he died that special relativity and general relativity were shown by GPS experimentation to be incorrect. But now that he's dead, they maintain that his work shows that special relativity and general relativity are correct. If you can believe that. And because originally, before GPS was successful, the physicists all would write articles about these poor, deluded engineers who don't realize that you can't possibly do what they claim they're going to do. And now the thing has gone full circle, and they're saying that, oh yes, Ron is right, and that proves that we're right. So let's see now. I got. The cancel culture continues in physics, and you cannot get any experiment done. There's something flashed on the screen here.
I just put it up. I'm sorry, but it's relative to what you said about GPS. I'm not quite sure if that's true now, what Professor Hallam says. They use the Sagnac effect indeed, but they don't use T dash equal T because they're using atomic clocks, which Jim referred to. And you do have to make a gamma correction for the behavior of those because of frequency change.
Which Sue derived, but also it does not affect, that's only something that takes place over a day. The actual
timing T dash
the actual
doesn't
timing of an individual
time is the same. But the recording,
actual timing of an individual pulse takes place in a tenth of in a millisecond, but or a tenth of a second, I guess, actually. But that is what Einstein's relativity can't explain. The fact that the clocks might have vary over a day or so
can't explain,
doesn't affect that one instant message calculation.
Well, the ether you say is made up of particles that are influenced by gravitational potential. That was one of the assumptions that Ron had too. He said that the density was affected not only by gravitational potential but also velocity relative to the local ether. So there was a twofold.
It's
and
there's two different
same with the
effects.
clocks. Yeah, twofold.
And
but it's a physical effect on it.
J.P. Wesley maintained, although he withdrew it because he made a mistake in his physics, his electromagnetic theory, but he maintained in his last book, Light a Photon Flux, that the ether was positron electron particles, which were then not charged because the positron and electron have opposite charges. And this is called positronium, I find out. And so
I've heard of that model. I don't particularly like it.
It seems to go along with who's that British physicist, Paul Dirac, who talked about a positron electron sea. And also some other people have been working on it. His name's
like Simony, the more recent. Simony.
Oh, is that right?
Yeah,
I think so. Yes.
So I think we're closing in on this, but the cancel culture out there isn't going to let. I have a complaint. I was talking to Ian before the meeting. I authored 2 books with Jeremy Dunning Davis of England, Unitarian Mechanics. The 2 books were on Unitarian Mechanics, Part 1 and Part 2. And now when he sends me an email, it's blocked somehow. He has to send me an email through his daughter, who then relays it on to me. So the cancel culture is advancing. I understand Great Britain now, they have a very tyrannical government. And of course, we're here in the United States, we have a similar problem, but hopefully it's going out with Trump coming in. But, the cancel culture, people talk about it like it would never affect them, but it does. I mean, now if I send Jeremy an email, I have to send it via his daughter. And when he sends me one, he has to send it by his daughter too. So you wonder how this can happen in a modern. I mean, people. what is going on
Well,
here?
obviously, that's even worse. I mean, if it's happening in that way, because the cancel system we see all around us is where they ostracize you and they won't speak to you and they won't let you have a talk and they ridicule you and so on. But this seems to be actual physical censorship. You know, the big hand
Yeah, they
physically
won't.
stopping you.
It started out when I would send him an email to his Hull University address after he retired. They would block it, and they admitted to him when he contacted them that because they said, "Well, we have to protect our reputation." But now this has nothing to do with Hull University. He said got us another email address, but he can't use it to send me emails anymore.
Yeah, it must be at a higher level than the service provider. It must be, the general national or governmental level where they're actually
Well, it could
censoring.
be
Sounds very worrying indeed.
Yahoo.com. It could be Yahoo.com is, I violated their ideology. I'll have to try to send it via Gmail, see if it goes, and then see if he can reply via Gmail. I don't know what to do. I just ran across this the other day.
It's very hard to look into it because there are algorithms. I mean, I know a colleague of mine about 25 years ago was participating in the European Committee dealing with the color codes of cables, and they were deciding whether the neutral should be the old system, which was black or something. The thing was stopped by the email because they thought it was a racial matter, the algorithm. So you never know where you are. But anyway, those are very interesting points, Denny. Any brief response, Jim, or do you take the point?
I actually met Ron Hatch at CNPS 2016, and I think he had a lot of good points. He even mentioned something about, I think, two satellites that were in the same orbit following each other. That showed a picosecond Sagnac effect. That
who is this you're referring to, Jim?
Ron Hatch.
Who'd you hear? Ron Hatch? Oh, yeah.
Ron Hatch.
And the NASA refused to accept it. His explanation, because they're the ones that, well, whatever. But
okay.
Yeah, and I also want to point out that one reason I'm skeptical of Miller's results, which I initially thought were good, but it turns out that he averaged his data to at least 1 decimal point more than the actual values that seemed very suspicious to me. I think other.
Yes, he did average. It shows in the plots I showed you on his book. He did average, yes.
And
it shows the actual data and the average, and the heavy graph. The darkest part was the average, which seemed, looking at the ones he was averaging, it seemed to be reasonable. You might look into this book. I know it's hard to get it. It's out of print, but you might be able to get it from a library or something. And it's, as I say, it's page 232 that he has these plots on.
Yeah, I also wanted to emphasize again that, the only way to overturn Einstein's relativity is to hit it at the fundamental level, because the Michelson-Morley experiment itself, because you always come back to that. Is how do you explain that? The null results. I'm just saying that they're not.
Well, it wasn't null. First of all, it wasn't null.
Well, that's another thing. Indeed, as I said at the beginning.
But
but
that would not be consistent with, say, the pseudo-range correction, which has no, which is all based on the assuming the reference frame is the ECI. There's no motion there's
Well,
no effect.
Ian points
There's no
out
effect.
that
There's no effect due to motion within the universe or within the solar system. It's all contained within the local ether.
You see,
Well,
a bit
Ian points out
controversially,
For example,
some of the
if
Ian
you're
points out
that's
if
the way they
matter
explain it.
partially entrains the ether,
it's not partial.
if
locally.
if
It's not partial in the vicinity of the
matter
Earth.
entrains the ether, yeah, if matter ether in its then you, as Ian pointed out, you can get the things to be correct. Isn't that right, Ian? If you assume that the matter only partially entrains the ether.
Yes, indeed. That's the system I use because there doesn't seem to be a total entrainment from experimental results. But I was saying, I mean, a geocentrist would probably say, "Oh, there's total. It's zero, absolutely zero, because we're at the center of the universe and we're immovable." Yeah, that's what he would say. But I agree with you that, yeah, I think there's partial entrainment, and I think it can be worked out mathematically. So I've tried to do that. And I think Professor Hallam Boutayeb has been making some other points as well, relevant to these. Mind you, he's talking about experiments in relativity. I'll not put up his comments. It's getting a bit late now, but he says, well, he's claiming, Jim, maybe that it's not only by experiments that we should be, if I'm interpreting correctly, attacking relativity. We can do it by mathematics as well. Well, maybe that's unexceptional.
Well, you certainly can show stuff, but to convince anybody, you got to show a result for the MMX.
Yeah. Okay. Well, thanks very much for those points, Denny. And we hope you're not cut off too much by the cancelling groups.
Yeah, if I can't send any emails anymore, I don't know what I'm going to do.
Maybe that's why I haven't heard from you for a little time. I hope not. I hope they haven't been censoring emails to me. Anyway, who knows? Who knows? So thanks very much, Denny. And we're getting near the end, and I do have one other thing to do before. So Slobodan, I see Harry doesn't seem to be connected, although he's logged in. If you can be as brief as possible, Slobodan, and maybe make 1 or 2 points instead of about 20. Just forgive me, because I don't think we'll be able to deal with them.
Okay, I always trying to make a very important and main point, to abstract many things, just to concentrate. Right? So I think Jim is fine with me. I mean, that is from the time when we talked in Washington, D.C., right? The 2016.
Yeah.
I was there, right?
Yeah, we're right next to each other.
Yeah, look, okay. MMX was designed based on the assumption that the light or M waves, transversal M waves, propagate in the ether in the same way as the sound propagates in the air, right? That means by wave mechanism or undulatory mechanism. It looks to me that you are sticking to that conceptualization of the propagation mechanism, and that's why you exclude the impact on the transmitter on the velocity measured by receiver, stationary or moving or whatever. Is that true?
There's an analogy between the two cases.
So is that true? In my view, that might be the biggest and most important misconception in all the work done. If we are to consider such a mechanism, that the only valid transformations are the Foicht's transformations. He specifically developed them, I said ingeniously, really, to cover that case. Lorentz just misused it to accommodate the contraction and whatever, So regarding this question, I would ask you whether the satellite vehicles transmitters also impact the velocity of propagation, so that also it could be taken into account in addition to the velocity of local receiver, And regarding the gravity, it would be rather the velocity of the ether, rarefied gaseous ether that penetrates Earth, and with actually with the first cosmic velocity just close to the Earth, that will be changing the results of Michelson-Morley experiments, not still the reason of second order kind of difference, but first order difference.
So you think there's a fundamental difference between transmission of waves, say in water or air,
Sound in air,
transmission in the
absolutely ether. For one thing, the light actually is the perturbation of ether by the essentially vortexing pairs, photons, that may be considered as a stone put thrown in the lake or whatever. And transverse electromagnetic waves are also propagating and being induced in the ether that has very high pressure of 10 to 36 kilogram per Newton per square meter. This is based on the Tchaikovsky's heterodynamics. So, that would be by that one can explain really very simply the Michelson-Morley experiment, but also those results that are producing positive outcome of the experiment situated on higher elevations are essentially due to the velocity of the ether as he goes down to the earth, and actually its pressure gradient is the potential function that you, Jim, mentioned related to the density and things like that. So,
okay, well,
that can be decided very, very simple. I shared the document with two groups, I think, two groups of internet discussions. Very simple experiment that emulates for one thing binary stars, and for the thing the transmitter and receiver of GPS.
And have you any take on Tchaikovsky's, if I'm pronouncing correctly, dynamics, Jim? So
no, I haven't heard of it. I'd like to point out that any model that talks about it like a varying velocity as you go farther, like I don't know how far you're talking about, but
he has
even out to the level of geosynchronous satellites, 30,000 kilometers.
Okay,
any kind of
it should be kind of continual.
Would screw up the pseudo range correction.
But pseudo range correction should be taking into account also the velocity of the satellite transmitters.
They don't. They're based on the location of the satellite, calculated from its orbital dynamics at the instant of transmission. Doesn't matter whether they're going away or up or down.
I have been repeating
just where it gets them in.
And asking you to pay attention. It might be very kind of misleading and I don't say naive or whatever, to all the time stick to the basic assumption of the manner of the propagation of the perturbation in the ether. I mean, light and the waves. They essentially, very likely, and that could be shown different waves, but a simple experiment.
I think, gentlemen,
the mechanism is emissionistic.
You are going to have to continue this, I think.
Emissionistic,
one basis.
We can get in touch, I mean, by
but get in touch with each other.
Maybe and I would ask James to send that Hatch's article, copy, if possible.
The one that was unpublished, is it?
To everybody. Well, okay, thank you very much. Sorry.
Despite my inclination for both theoretical and practical experimental reasons to reject time dilation or time change, I'm being converted somewhat to a view of time contraction, because it seems that every time we start an interesting conversation, the time just catches up on us. So, so thank you, Slobodan. And I hope maybe you get some further.
Really, Carlo, there's just two options. The relativistic mechanism is totally unphysical, you know. It can be totally discarded, and everything that comes after that. But this is important. Is it a wave, undulatory, or emissionistic, like Christian, Newtonian?
Okay, well, thanks very much.
Okay, thank you. Thank you, bye.
Thank you. I'm sorry for being a bit short cutting it off. Because what I have to do just before talking to Jim again and closing the meeting is I might put it in David de Hilster's own words. He's the, I think it's somewhere here, he's the president of the John Chappell Natural Philosophy Society. And I've got a 2.5 minute little spiel about the fundraiser, which is current. And we normally play that at the end of the proceedings. So I'm going to play it now with your permission, and then I'll physically come back to Jim and close the meeting.
Hello, everyone. I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our 3rd annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system, several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
And on behalf of CNPS, I'd like to thank everybody who has contributed already, and thank you for your consideration for the future. Now, so what I'm going to do, Jim, as we're just reaching the end, is I'm going to give you a minute or two to say anything you wish, to summarize, or to say you've said it all, or to, in the light of any of the discussion we've had, maybe to make any further point. So I'll give you the floor just for as long as you want, some minutes.
Thank you. Yeah, I think I've said what I was trying to, the points that I was trying to make. I missed some interesting ones, but again, the elephant in the room, or the 800-pound gorilla, whatever you want to call it, is the MMX, Michelson-Morley experiment, and it's supposedly null results. And you really can't try to dispute Einstein's relativity unless you can prove that that's an incorrect assumption. That assumption that it's too small to measure unless you're looking for it the right way. That's what we got to do, and I don't know how to get it accomplished. I haven't really been pushing it. I don't know how to push it in terms of getting money or support to actually try it. So that's what I think is the first step to going forward in terms of fixing physics, and it's crucial. Thank you.
Well, it's my pleasant duty now to thank Jim very, very much for having taken the considerable trouble of presenting to us his consideration of this very fundamental subject, the origins of relativity and the mathematical basis thereof, and the experiments that have been done or ostensibly done and interpreted in various ways, and his suggestions about how we might home in a bit further on what he understands to be the truth. Because some of the experiments have been misinterpreted, and we talked about the Ron Hatch's experiments, which ostensibly would have said that there's a contradiction in the relativistic principle, that there's no effect because of the motion of the Earth on the GPS receiver and so on. They are now being used to I think Denny indicated this, to say that this is a further proof of the special theory of relativity. So things have been twisted around, completely twisted around 180 degrees. And for my own part, I'm a bit of a skeptic about all this as well, because I think there's an orthodoxy there that doesn't want to be upset in any way. And indeed, Jim did recognize that. But, if you do think that the truth eventually will come out, I think all these endeavors, including the very substantial ones of Jim, will bear fruit. And maybe in the long term, perhaps long after we're gone, I don't know, I'm being realistic, perhaps, Jim will be recognized as one of the pioneers in having broken this stranglehold upon us and allowed us to engage in fresh thinking. Because it has been said that things that start as heresies become accepted, and then they become dogmas. So this can happen again. And by the way, Professor Hamlin, I think, has raised a number of points which you weren't able to go to. I've just put my email address in the chat. So if Professor Hamlin or anybody else would wish to talk to us in the new year, maybe in the early months of the new year, he might like to get in touch with me, and we can discuss that further. It's not my pleasant duty now to have to terminate the meeting, because we always have to curtail some of the interesting conversation, especially towards the end. But this isn't the end of the matter. We will keep in touch with each other. We hope Jim, through his participation, will continue to make these points, and perhaps we'll ask him back at a later stage to give us an update on what's been happening. So thank you all very much in the social media for making your comments. I did my best to capture them, but I know some of them were not dealt with. And thank you everybody in the green room, particularly those who contributed today. And so I'll end the meeting, and I'll wish you all, wherever you are in the world, a very, very good day.